Oh. Alright, so today we're going to be working on, or we're going to be learning about computing the square. And we have some learning objectives and key vocabulary that we have to go through. So today we're going to be formulating a strategy. So can somebody actually read the definition of formulate for us?
Create or devise methodically a strategy or proposal.
Alright. So can somebody give me an example of formulate? How can we use that word? And you should see it on your graphic organizer. There are some examples in there you can refer to.
Carmen has formulated a strategy to solve the problem.
Alright, so today we're going to be working as Carmen. We're going to be actually formulating a strategy for computing the square. So I want you guys to do this really fast. I want you guys to factor the following expressions. And all of you kind of know how to do that. We're going to do that on our activity sheet actually. There's going to be some space in there for you to factor this. So just take your time. Alright, so now let's speak, pair, and share. What do you guys notice about that, about the expressions? And when I say about, for those there. So can you guys pair up together? You're going to think about that. And then what do you notice about those expressions?
They were called perfect square. I put
You mean they're both sides?
Those are the same.
Well, I think there's just
It's the same.
expression because it has
Oh, yeah.
What do you guys notice in here?
I think we have different answers. X plus 5 square. Yes, X plus 5 times X plus 5.
Okay, so what x plus 5 times x plus 5 represent? Yeah, it's the same idea. Yeah.
Oh, like 2 times 2.
Yeah. So this is another representation. How about you guys?
They're all.
See, you're working on
I was saying that the expression, that these expressions could be called perfect squares.
Yes.
But she said that only numbers can be called perfect squares. And we don't remember the vocabulary.
So what happens if you plug in a number for x?
But it becomes a number.
It becomes a number. So remember that variable is just a representation of the number.
So is this just one big number? And so if 25 is a perfect square, then
Yeah.
21 plus 4 is.
Great job, guys. So I was looking around, and can you guys shout it out for me? What do you guys notice about these expressions? Yes. They're all perfect squares. Look at that. So A is x plus 5 squared, B is x plus 4 squared, and C is x plus 1 squared. So I figured that we don't have enough teams, but so I want you guys are gonna be team A, and you guys are gonna be team B, and you're gonna be team A as well. Okay? So you're gonna be using your algebra tiles, so get those out. Algebra tiles and your math to factor the following expressions.
So we have x squared
Yes.
plus 4x plus 4. Okay. So we have x squared
We have 2 X's.
4x.
And if you guys just forgot how to do it, we have some reference sheet, but it's on the back of your paper, of the algebra map.
So I think that we get this because that's x squared.
Same.
Those are 4x's and those are 4. So then we would have this. I don't remember how to get the factor out of it.
Square. So then we have, I think we put, and then we
It's also a bracket factor as well.
on the outside.
Wait, how do you get
These
the
are
factor?
these are the factors.
So the factor is like this, is x. What do you need to get an x squared? You need two x's, right?
Oh.
Right? What do you need to get one x and one x? You get one there.
But how did you know, so that was nice because we had that here.
Yeah.
And then we could see we needed that here.
Right.
But if we're working from scratch, how would we know?
Well, usually we do this portion first and then we do the factoring.
Right, but like here,
I don't think so.
put in x.
So,
Here?
yeah.
So you have one there.
Well, if you have an x there,
Oh, then a one will have to go down here. Yes.
So,
exactly.
what do we do?
But that doesn't make sense because
There's actually not.
you're gonna have to have an x here to make this x squared.
I couldn't have another x squared.
So then.
You're gonna have to have two x's here so you can make an x squared.
Okay, okay.
So these have to multiply to give.
Exactly. So this is how we multiply x times x equals x squared. X times 1 will give us our
Oh, okay.
One's over there.
Yeah. Oh, and then like one times
What are we
that
doing
would be
here?
like
So, that's what we got it, and it turned
I
out.
see that you're doing something different.
Yeah, well, I have it like this, which I think that's what yours is supposed to be, but I was just like, well, I didn't know, like, what if I put it like this, like, what if
Yeah. Can you try that?
I think I'm gonna have to add more.
Yeah, you're gonna have to multiply times 1 with your
Yeah.
ones. That's gonna
just
be
looks
complicated
like
things.
this.
Yeah. Very good. What are we doing here?
Doing good.
You'd be getting an accident.
So do we always have to leave this stuff on the inside of the square?
Because I made it a rectangle.
So I
Yeah,
just.
if you make it a rectangle, then it's not gonna work as you say.
Could we have
Like, we
started?
can put this, all of this in here.
Yeah, that's what I had it.
Yeah? Then we have to have this
Oh,
one
just
here because
like this and
last
this.
Yeah,
one.
well, I had it,
We have to
I
put
like,
that
so I made it
somewhere.
like there.
Yeah,
Like,
instead of completing the
That
square.
one there.
Yeah.
And then you're gonna have to
And
have.
then, yeah, so.
So
so
one
like-
here.
Yeah,
Yeah.
so it's X gets you X.
I think we would give
Right, right.
Yeah.
the air,
So you're giving this.
we're given that, we had to.
So once again, guys, what are we noticing about the expressions above?
Perfect
Perfect
square.
Perfect squares. Good job. And you guys can see the square on your algebra tiles as well, right?
Yes.
Now we're going to look at the last number of the expression on your algebra tile. What do you also notice about this number? What do you notice about that number as well?
Oh, perfect square.
It's also a perfect square, right? So we have to keep that in mind when we try to develop or formulate our strategy. Alright, so we're going to help out a friend. And make sure you're writing all of this down in your activity sheet as well. So, Michelle, your friend, wants to build a square with her algebra tiles. She has 1x squared and she has 6x tiles. We're going to use the algebra tiles and the math to find how many tiles Michelle needs to build how many ones she needs to build a perfect square. So explore, you have 1x squared and 6x tiles. So how many ones does she need? So use your algebra tiles to explore them.
What do you think?
I just like looked at the
Yeah, X
picture.
square.
And I tried to put in one. So I got 9.
So you're putting 3 on one side and 3 on the other side. Right?
Yeah.
Why are you doing that?
Well, I wanted it to be square. So
Yes.
I wanted there to be like this thing on each side.
Exactly, yeah, good job. So why did you do your setup this way?
Because it's
So because you want, because
That's
this is the
why
same length,
Okay.
Yeah.
so then you want the same
Is there another reason for
length
that?
on both sides, is
Why
that
did I
is
say
that why
that?
you did that?
Yeah.
so that.
Because
Could I have
You
put
got
all
it.
the axes on this side?
Well, no, because when I did the big rectangle, then I had like axis times one.
I don't know how we work
One
those, so
times
it's like 7.
It's actually, yeah.
What, okay, I have a question. So, well, we have 6 axes here, so I can like split it here or But what happens if there's 7 here?
7? Oh. We're gonna actually go over that tomorrow.
Okay.
Yeah.
She already, like, this is what she already has.
So that's a really interesting
She already
question.
has it set up. She's like,
But the idea will be actually just to break up the algebra.
This is
Actually break it up. Half.
Oh.
Then do
This is
it.
the axis just have to
Okay.
So tomorrow we're gonna be working on this.
Axis just have to keep it.
So how are you guys doing here?
Good, but I
Six
think
is
around
not
it,
perfect square, so you don't
for what she could have differently with the 6 axes, and we looked at that, but then we just, I realized it wasn't actually a square rectangle. So then I realized why she has to do it this way.
Yeah. And she wants to build a square.
Right, I was trying to see if there's other ways. My other question was, how come if I want to build
It
square,
doesn't look like this though.
can I go like this,
Yeah.
and then
I think that's a square. That's a square.
you make
Yeah.
a bigger square
Can we switch?
by adding lots of tiles?
So what?
Like, can we
And
move these
try to
around?
make a bigger, would that work as
Well, this means that you're gonna have to put a 1 here, right?
Right.
Right? But then that means also you're gonna have to put a 1 here to make
Well,
this 1 times
If we
1
look
is
at
1.
how to do it on the
But
other side.
Now you're gonna have 1 here, now you're gonna need to put
X
a
here.
and then that's gonna complicate
I
things.
say the x squared is always kind of in that corner, right?
Yeah,
Well,
that's where it is.
So if I have an X
But yeah, if we put like,
here. Oh, but again, I would need a
Because
root
yeah,
X to get
split
this
up the
plus
X.
1.
What's gonna happen to
Yeah.
this?
Oh, okay. So it's not possible. Yeah, but I'm gonna.
Oh, great.
This is really good.
Why can we split x?
I really like that. This is really cool.
So I want you guys to think, pair, and share. What do you guys found? How many ones do you guys need?
9.
9, yes. Good job, guys. So we have been working a lot with algebra tiles now, but, and this is how it should look like. And this is the way we express it. We say x squared plus 6x's, we have 6x's, plus 9, and we have 9 tiles. But now, Obama, your friend, also wants to build a square with his algebra tiles. He has 1x squared tile and 12x tiles. And if you guys notice, you guys might not have enough tiles to do this. So, I want you guys to use what you guys have learned before, and I want you guys to find how many 1 tiles does Obama need to build a perfect square without actually having to use the algebra tiles. So apply what you have learned in previous exercises to find this number without having to construct the algebra tile.
know how to do it up.
What have you guys noticed on the other exercises
When you said like
Well, I
when you
need
divide it, what did you say about dividing?
to find this number?
oh, so I split it into 2.
It probably shouldn't be a circle.
Oh, so
Square.
we're
Yes. It's not
So
a
if we
perfect
divide
square.
12 by 2, we get 6.
And
And then I don't know.
then it's gonna be what is it? What's
So
the
then
number?
we have 6 ones.
Yeah.
6.
Why not?
How are we getting that 6?
I
Where are
was-
we getting that 6 to work?
Sorry, I didn't even know. 6 is like
So you, well,
Well, we got clearly we're gonna have square here. That's 6 by 6.
Oh yeah, half of that.
Yeah.
Yeah.
So if we want to write this in expressions, we will have x squared plus 12x plus some other number. And we have to find a relationship between this number, the number of x's, and the number of ones in the expression, right? Yes.
Laura was saying we can, like, we split, but then the last one we split it, like the 6
Yeah.
X's, we did the 3 and 3. So you can do, like, if you wanted to use algebra, 6x and 6x, but how do we know how ones
Yeah.
would be? That's how do we use that to find ones? That's what we're having trouble with.
Yeah, so you have 4 x's here and 4 x's here, right?
Like with the algebra
You
tiles.
kind of have it.
Well, from the other one.
For the other one,
Half.
okay, so let's take this one out.
6x.
And let's actually use what we had before here. We had 1, 3 ones, or 3 ones on the other side. So this is half of our x's, right?
The 3 for the last one. Yeah.
Yeah. Now what are we doing to get this number?
There were 9 of them. There were 9 items.
So what are we doing to get that number?
What's the area of that square?
Yeah.
9.
And you got that from multiplying 3 times 3, right?
Yeah, that works.
Okay.
So what's our strategy?
Taking half
Yeah.
the x coefficient and
So what do you guys found for this last one? For 12x plus what? 36? Everybody agrees with that? Excellent. So now I want you guys to formulate a strategy to complete the square. We saw actually using algebra tiles or any expression. So write down a piece of paper, and that means like the bottom. What's your strategy to completing the square? How are we going to get that last number? And try to use your examples that we were working on to try to come up with that strategy. So I'm going to give you guys a few minutes to
I disagree with your formula.
So we're trying to figure out how to get around.
Yes, how to get that last
You
number.
have this.
So you got 36 on this one, you got 9 here. You got 1 and 4 here, you got 1, 16 and 25 here. How are we getting
So
those
one half
numbers?
actually goes
How are we constructing that complete
square.
square?
So that means I have to multiply the beginning by 1/2. I think it would be 1.
For one side, yeah, we split it up.
And make sure your strategy is so good that you can give it to another group and they can follow what you're doing.
Oh, I need to do it.
Say half of the x coefficient and square.
So you're multiplying.
Do you agree with that?
Yeah, to like the
So what?
other tiles, say
How
like.
would you write that?
Do you guys
Like,
got that
What's
based
the
on observation? Or you guys
We just like looked at the picture
Take the
and
number
like, when I
before.
tried to find 36, like I counted how many were here.
It is 1/4 squared.
But then you have
Divide by
squares,
two.
6 times 6.
No, no, this
Five
is,
times
I'm totally.
6 was
And
times
then
the
one
number
by
of that you're.
I'm saying that that is the same. I would realize that that actually also.
So what are you guys' strategies?
Right, I don't know, maybe also came out from that. I was talking, yeah,
What
I
number are
was
you
talking
talking
about
about?
1/2
that middle one, the
square that.
before the X.
And if you was
How is that
talking about
coefficient?
Yeah, on the
Yeah,
coefficient.
yeah, okay.
So we divided the coefficient.
So first I was like,
by 2, and then, so for.
And then you wrote this, and I'm like,
the
that's
area.
No, yeah, I
So we
agree.
really
Those.
defined it,
Yeah.
right?
Yeah, exactly. Yes.
so we write that, how are we gonna represent that like mathematically?
We're gonna do that later. Yeah.
Good, so I originally disagreed with her.
Yeah. What was your disagreement?
So this is what she wrote.
No,
And I said that, well, no, that's wrong, because if you square it, you get to 1/4, and we didn't want 1/4, we only wanted 1/2. So then I said it's 1/2
But
times.
this x coefficient, this is a number of coefficients, or actual
That's the
coefficient.
actual coefficient.
So the coefficient 12.
Yeah.
So half of that is 6.
Right.
Squared.
Right, and then she made the connection that it actually is 1/4 x squared. I said it was everything wrong.
Oh,
Same
great.
thing.
That's fantastic.
Yeah. Good job.
Thanks.
Yeah. Alright, so to end this, I will have you guys exchange your strategies and you will apply them to find this one here. And we have some interesting things going on as well here. We got some negative and then we have 3x. Does your strategy actually works for odd numbers? Does it work for negative numbers?
Okay.
Yeah. So by doing this, you will explore it. Then that will be it because we have
And you know, thinking we got 49.
Oh, it's been 21.
21, oh. Yeah.
So that's 1 point.
Yeah, so after we do this, we go over this one, and then that's pretty much the whole activity. Okay. And of course, this could actually be applied to a 50-minute lesson. It's just that you